Hello everybody, welcome to the video. Today we're going to be going over the law of sines, but the side-side angle ambiguous case. So the word ambiguous kind of means unclear. Like for example, if I was talking to a bunch of people and I said, hey you, and I didn't really specify who I was talking to, then I would be ambiguous. So that's what this word means. So we're going to talk about the ambiguous case for applying the law of sines. So before you watch this video, I want to make sure you guys all understand the law of sines. So make sure that you watch my video on that if you haven't done so already, about how to use the law of sines in order to find out angles and side lengths. Okay, so I did mention that ambiguous means unclear. So what that means is that for side-side angle, there could be three different cases, okay? There could be no possible triangles, there could be one, or there could be two possible triangles given certain conditions, okay? So I want to give you some visualizations to help you understand what's going on. So the ambiguous case for side-side angle. Suppose that you're given two sides, call them A and C, and you're given this angle A across from this little a. So you can make a triangle like this. However, with side-side angle, the reason why this isn't a triangle congruence theorem is you could actually have another triangle that has these same conditions. And that triangle is created by taking this segment A and swinging it over this way. So that's going to look like this, right? Now notice that these two triangles have still have the condition of angle side-side or side-side angle, right? So this is what's going on with the ambiguous case. And over here in the first triangle, we call the angle across from little c, we call that big C. And notice that here, the C changed. It went from an acute to an obtuse angle. So we actually call this one C prime, all right? Even though this little c and this little c is the same, C and C prime are going to be different. So to solve these problems, you should know the relationship between C and C prime. So take a look at what I drew here. Here, what I have is the original triangle drawn on the second one. And notice that in this dotted triangle right here, this triangle is isosceles. And the reason for that is because these two segments A are going to be the same. Remember, we take this A and we swung it over this way. So these two segments are going to be the same, which means that these two angles are going to be the same, right? So with that, you can basically tell that C and C prime are a linear pair. And what does that mean? That means they add up to 180 degrees. And with a little bit of algebra, you're going to see there that you'll see the relationship between C and C prime, okay? So guys, for the ambiguous case, you're going to solve the triangle like normal, but then you also have to solve a second triangle with those conditions, and the link between these two triangles is C and C prime. So you need to know that C prime is just 180 minus C, okay? All right, so let's go over some examples now. So example one, we're going to solve the triangle with these conditions. So we're going to consider a triangle with angle C is 33 degrees, angle B is 10, and side length B, little b, is 10, and little c is 6. So you're going to see conditions like this. So in your guys' homework, just go ahead and sketch it. It doesn't have to be perfect or anything, but just, sketch a triangle like this and label all the side lengths, little c, little b, and the angle C is 33 degrees. And then what you're going to do is use the law of sines like you normally would to find all the angles and side lengths, okay? So what I want to encourage you guys to do before you move on with this video is to go ahead and figure out, using the law of sines, what the angle B is, and then use the triangle sum theorem to figure out what A is, and then figure out what this segment is right here, which would be little a. So go ahead and see if you can figure it out using the law of sines. Okay guys, welcome back. So let's figure out what angle B is, right? That's going to be, this is the setup. So the sine of B over 10 is equal to the sine of 33 over 6. We do a little bit of algebra here, right? We get the angle B by itself. We plug that into the calculator and we realize that it's 65.2 degrees. All right, that's what you should have gotten. So go ahead and put that on the triangle. Then, like I mentioned, we're going to use the triangle sum theorem and the law of sines to figure out big A and little a. So if you're not sure how to do that, you should definitely let me know, but this is what you should get for the first triangle. Now, because this is angle side-side, there could potentially be a second triangle, which you have to solve for. So that second triangle is going to look like this. Here you have the angle 33, and here you have the segment B, and here you have the segment C. So after you draw your second triangle, after you take this segment and swing it over this way, you have to find B prime. And remember what I said in the notes is that the two angles B and B prime are a linear pair. So in order to find this B prime, just take 180 and subtract the original angle B. All right. So if you go ahead and do that, then you'll get well, the original angle was 65.2. And then if you subtract them, you'll realize it's 114.8. So let's go ahead and label that one right there. Okay, then what we're going to do is once again use the triangle sum theorem and the law of sines in order to figure out a prime and little a prime, and that's what you should get. Okay, so the new thing here, guys, for angle side side is there could be potentially two triangles that you have to figure out. Okay, all right, let's go over another example. So suppose you have these conditions where angle B is 79 degrees and segment A is 17 and segment B is 18, okay? So we draw the triangle just like this, angle B, little a, little b, right? Then what we're gonna do is label everything else, big C, big A. All right, then what we're going to do is just use the law of sines and the triangle sum theorem to find these two angles and this segment, okay? This was review. You should know how to do that, but of course, if you don't, let me know. So once again, we're going to need to take this segment right here, little b, 18, and sort of swing it over this way. So you get something that looks like this, okay? Remember, this is our angle side side. So the angle is 79, right? The little a is 17 and the little b is 18. And we're going to need to figure out what this a prime is. So knowing that a prime would just be 180 minus the original angle a, we can plug in 68 for the original angle a there and realize that that's going to be 112 degrees, okay? So what I want to encourage you guys to do is to find the new c prime and the little c prime right here in order to complete this triangle. So if you do that, you might find that there's something wrong, because actually what's happening when you take 180 and subtract 79 and subtract 112 is that you get a negative angle. You get negative 11. So what's going on? Well, how could we get a negative angle? What is happening? So what is happening actually is that this triangle, this second triangle, is impossible. And the reason for that is because this segment right here, 18, is too large. I can't swing it over this way in order to make another triangle, even though this is angle side side. So when you work on your second triangle and you get that an angle is negative, that means that there's only one possible triangle. And this is it right here. This would be the possible triangle, okay? So like I mentioned, if the angle is negative, then just cross it out. That triangle is not possible. There's only one possible triangle, okay? All right, so let's go over the last example. Example 3, we're going to solve the triangle or triangles with these conditions. So we're going to consider a triangle with the angle is 33 degrees, this segment B is 10, and this segment C is 2. So we're going to draw that 33-degree angle right here. We're going to put little b right here, and we're going to put that this little c2 is going to be right here. And once again, notice that big C and little c are across from each other. Okay, then we're going to set up the law of sines like we normally do. So the sine of b over 10 is equal to the sine of 33 over 2. And we're going to do a little bit of algebra, multiply 10 by both sides, all that stuff, solve for b. And we're going to take this and plug it into our calculator. So the inverse sine of 10 times the sine of 33 over 2. Now, when you do this, what ends up happening is that actually you end up getting an error, okay? So what's going on here? Why did you get an error? The reason why is because this segment C right here is actually too short, okay? No matter how you swing this segment over to this segment B, it's not gonna hit this segment BC right here. So if you get an error on your calculator on the first triangle, that means that there is no possible triangles. So this is an example of no possible triangles, okay? Okay, so what I want to do is kind of summarize everything for you here for solving a side-side angle triangle. The first thing that you want to do is just draw the triangle with those conditions, all right, just like right here, angle side-side. Then what you want to do is calculate the unknown angle across from the known side length first, okay? So calculate this angle B here first. If you get an error while trying to calculate this angle, that means that there's no possible triangle, just like in the case for example 3. But if you can figure out what B is, you want to solve the rest of the triangle. So figure out what C, angle C is and what little c is. So you want to solve the rest of the triangle. Then for step 4, determine if there can be a second triangle, and you want to calculate B prime, or whatever the variable is, by subtracting B from 180. And then you solve the second triangle. If you get a negative angle at any point, that means that you can cross it out, and there's only one possible triangle, just like example 2. But otherwise, there's 2 possible triangles, just like for example 1. All right, so that's how to solve triangles with the side-side angle conditions.